and gentlemen, welcome to the Fiber Connex 2020 conference, brought to you by Digital Council Africa and headline sponsor, Inc.
Good morning, everyone, and welcome to the next conversation this morning at the Annual Digital Council Africa. It's a real pleasure this morning for me to welcome the team of Inc. We're really grateful, Inc., for your sponsorship of this event. What a critical conversation to be having and to continue these conversations in Africa. And of course, today we're having a conversation that's very near to my heart. We're talking about 5G. And for those of you that are not aware, the Digital Council has done a series of events around 5G. We've considered already 2 years ago, we've developed some white papers around the densification of fiber in 5G networks. And we continuously strive to partner with companies that have equal interest in the conversation of 5G. So without further ado, this morning it's a big privilege for me to welcome two members of the Inc. team, Mr. Duncan Pai and Mr. Pramod Venkatesh. Mr. Duncan Pai is the Group COO for Inc. He's got more than 22 years of professional experience in the sector already, in financial services, IT, and telecoms, with a focus on strategy, product development, sales, strong people manager, and executive team member. He's previously worked for Microsoft, Botswana Telecoms, and Dimension Data, and he's based in Botswana and works out of Botswana. Joining him is Mr. Pramod Venkatesh. He is the Inc. Group Chief Technical Officer, CTO. He's got 10 years experience in the field of cloud, AI, DevOps, SDN. He's a technology and team-orientated leader, and has got a successful track record spanning pre-sales, product management, architecture, marketing and operation in the field of DevOps, clouds, and software-defined networking technologies. So both of you seem to be jack of all trades, really phenomenal experience, and a great honor to have the Inc. team with us this morning. Real privilege. Speaking this morning on that topic, as I mentioned, that's really close to my heart. Topic titled Building 5G Networks Openly. Duncan, I'm really looking forward to the session.
Thank you, Anita. Thank you. Too kind on the profile. We really appreciate it. So Anita just took you through our profiles, and these are the faces that she was talking about. So good morning to everyone. Thank you very much for joining this session. We really appreciate you taking your time to come and listen to us, share with you our insights, and we would be looking forward to the feedback from this session. We really appreciate it. Thank you very much. Just as a start, maybe just to share with you who Inc. is. We are a majority-owned company by Convergence Partners. Convergence Partners is a private equity firm that invests widely in IT and telecom. We've been around since 2013. Not sure if we are kids or we've been around the block a few times, because IT companies sometimes tend not to last, but we're going towards 10 years now. Incorporated in Mauritius. We have presence in 8 countries and 16 cities across Africa. As you would see in the map on the right there, these are the countries where we have presence: South Africa, Botswana, Zambia, Malawi, Nigeria, Cote d'Ivoire, and Cameroon, where we are pending regulatory approval so we can fully take it over and change the name to Inc. The operations in Zambia, Nigeria, Cameroon, Cote d'Ivoire, we acquired them from Vodacom Business Africa. So some of you may be familiar with them from when they were still under the Vodacom belt. We are also expanding our reach and portfolio into Kenya and Ghana, and we hope to be in these locations within the next 12 months. And what really is driving this expansion and growth is that we have a single purpose of being the #1 cutting edge multi-cloud digital service provider in Africa. What this means is that we've selected a few areas for our product offering that we believe we can pioneer within the African continent. The first one is our video analytics, which we have developed in-house, and it's gaining a lot of traction across the markets or anywhere where we have engaged our customers, especially in these days of COVID, where compliance to regulations and social distancing is a key topic. So we utilize our video analytics to ensure that our customers are able to enforce compliance. There's also other aspects around video analytics, like intelligent security, retail analytics for those in the shopping arena. Then we also have our SDN offering, given that traditionally our businesses come from the ISP background, and we see the market shifting towards SDN. At the end of this slides, we will put up our website, where we invite all of you to visit it, indulge, and get understand a lot more of our solutions. During the conference as well, we will have a virtual booth that will be manned by senior leaders of our business, and we will gladly welcome you there and share with you a lot more of all the exciting things that we are doing at Inc. To preface our discussion on 5G, we thought maybe just start by taking you through how spectrum is debated and allocated every 4 years. This slide is important because when we start discussing 5G and what it can do, we'll then understand how the spectrum that is used there comes into play, aids as well the forecasting around what we should expect to see in the next few years. So typically how it works is there is the World Radio Conference under ITU. They work in 4-year cycles. So they choose spectrum that people have to go away and study. And the spectrum that people go away to study is the one that would be allocated at the next WRC conference. So if we start with the 4G spectrum as an example, these conferences have been going on for, I think, over 100 years from the very first days of ITU. The 4G spectrum study was in the WRC in 2007. And in 2012, that's when it was allocated. Today, we are in 2020. So it's been 8 years since the 4G spectrum was allocated. A lot of our countries in Africa are still on 4G. So it's time for us to really catch up and move to 5G, because in 2023, the 6G spectrum will be allocated, and we don't want to be 2Gs behind. The 5G spectrum, which we'll be speaking about, the study was commissioned in 2015, and last year in Egypt, 2019, the spectrum for 5G was allocated. The bands as shown there in the screen, 3.4 to 3.6, and then there's also others for millimeter wave, 26 to 28. So it's important that at this point we start thinking about 5G, how best we can utilize it, also taking into consideration that the device manufacturers will also be starting to invest a lot of R&D on 5G, and any lag in our spectrum usage means that we'll be using devices that are not being researched and continually updated. A quick slide here is that what we are seeing as well emerging from 5G is the introduction or the change in the business model. The previous Gs, 2G, 3G, 4G, have largely been driven by MNOs, and they would offer mobile broadband, maybe with an element of voice. And whenever corporates, enterprises wanted to use that, they were compelled to provide their services within that flavor of the MNOs. 5G is changing that, hiking to the introduction of private 5Gs that are bespoke, customized to the needs of the enterprises. And our presentation today would be speaking largely about that. The critical capabilities that 5G offer is that it enables any enterprises that have built a 5G network to be able to influence the level of availability and SLAs of those networks. This then leads to having more reliable and better running networks that can facilitate interworking. Interworking would be, say, if it's a manufacturing plant and they have spin-offs of additional suppliers that bring specific inputs into that manufacturing plant, they can even extend these networks to them so they can easily manage and monitor how the conveyor belt for that supply chain is moving, to be able to proactively determine if there's going to be issues in the conveyor line to address that. So it does facilitate that, because they'll all be working off the same network, same rhythm. Similarly, quality of service in terms of network, as I mentioned in the previous slide, today's MNOs, when they provide services to private enterprise networks, it's a vanilla flavor from how their networks are architected. There is nothing specific to that enterprise. And what then this does is it robs them the quality of service for them to be able to determine and prioritize what workloads they need to be delivering at a certain time. And then security, as we know, it's a big issue nowadays. Any business wants the comfort of knowing that the environment is secure and they can work comfortably with that. And a private 5G network or any private network will give you that level of security. The business drivers for that is connectivity, speeds of hundreds of megabits per application. So what we are seeing is enlarged facilities, be it ports, factories, malls. Videos are very pervasive and common around this. There's a lot of information and insight that comes out of videos that can be used to run these places a lot more efficiently. So the connectivity then becomes key. And in a private 5G network, because the operator can determine the workloads, the quality of service to specific areas within the precinct, then they are able to work a lot more efficiently. Reliability, I touched on that in the previous slide, that greater control of the network facilitates that the enterprises can then be able to have a higher uptime. An interesting one is the one on the top right there on massive density, where we are seeing that the exponential growth or number of devices that can be handled on a 5G network is substantially a lot more than 4G. What then this means is if we take a massive area, say it could be a port, where today they would be running 4G to connect the different, say, cameras or machinery they have in there. When they reach a certain number of devices, then they will start hitting bottlenecks. 5G just offers them the ability to be able to ramp up the number of devices they can support in that specific area. And when you transpose this into that, almost every device that we have access to nowadays, it's IoT enabled. What we foresee is a lot more devices coming into a specific area. This could be bring your own devices, like customers coming into that area, or devices that are used by that business. So it's the one thing that we believe will be a driver for private 5G. And then the latency as well. I think Pramod will touch on this, that when we have interconnected devices. Okay. So at this point, I'll hand over to Pramod to share with us just typically how he sees 5G networks being built. Thanks. Over to you, Pramod.
Thanks, Duncan, and good morning, all. And thanks for the opportunity for us to kind of present we as Inc. In terms of as we continue through the path of cloud and digital solution. One of the key aspects is adopting 5G networks and how it's going to transform, not just in terms from a consumer point of view, but from a business point of view as well. So up to this point, we had Duncan, who was mentioning about the private 5G components and the ability in terms of, how private 5G is going to be the next wave in which the industrial revolution or the fourth industrial revolution would actually happen on, right? So one of the key aspects we need to consider about is we all understand that private 5G networks is going to transform the businesses, and adopting and building these unique small networks with powerful interfaces will help in accelerating the adoption of cloud and digital services in all these industries. To facilitate in building a private 5G network, we need to first kind of delve into what are the different components of this network and how each of these components will work together to actually facilitate this, this entire chain. So there are three aspects we kind of look at. We look at the customer premise, where in which this is the place where you will actually have the endpoint where you will have the radio station, where you will actually receive the data packets from the different user endpoints. And from that point of view, then we have the edge network, where there is real-time services, which actually provides the ability for for the protocol stack of the 5G to be transcoded and analyzed, and then sent back into the central unit, which is basically where the core network really lies. The core is where you would have the user data network, and you would also have the analytics and the billing and all the different components of actually maintaining and managing the private 5G network would stay. So in a private 5G network, in all these different components, rather than being owned by a MNO, would be owned by the industry which is rolling out. Now, there are two aspects in terms of building this. One is the entire, even the spectrum would actually be part of would be purchased by the manufacturing entity or the end customer directly, or the spectrum could be leased for that specific region by an MNO who might have a national license or so. As part of this entire elements, one of the key aspects is the ability for industries to maintain their own network, because what this gives them is the advantage to build the network based on the applications which they are running in their endpoints. So if it could be, for example, for video surveillance or robotics, for example, there's a requirement for the network to have extremely low latency, but with high throughput, right? And with minimal loss. So this kind of creation of these networks is very important for enterprises, because an MNO would be building, as Duncan mentioned, a vanilla flavored entity which might not be sufficient for these industrial use cases. So as we continue to look at, we need to understand how the private 5G spectrum and what is the benefit of having this private 5G spectrum is all about. Now, when we look at the private 5G spectrum, we have these spectrum divided into three buckets. We have, the sub 1 gigahertz spectrum. This sub 1 gigahertz is primarily used for low bandwidth and long range services. And this is typically used in rural areas and places where it's very hard to build extremely dense base stations, where that is where the first requirement is. And then we have the sub 6 gigahertz for mobility. This is where we typically look at the most of the private 5G network would basically run on this spectrum. Because the reason is, first, it helps us in terms of the higher bandwidth capacity, which is not available with the sub 1 gigahertz spectrum. And it also provides the industries to actually roll out not extremely dense, but rather slightly far apart radio stations and based units compared to like, let's say, a millimeter wave. The last one we are looking at is mainly in the 24 to 28 gigahertz spectrum, which we typically call as the millimeter wave. And this is the one which provides the true 5G areas in terms of high bandwidth, ultra low latency. But since because of it's being in the millimeter wave spectrum, it's most of the endpoints is assumed to be fixed, whereas in the sub gigahertz, there's a concept of mobility between multiple towers, and hence it's more useful for applications which are in motion, compared to the millimeter wave, which is mainly used for end user endpoints which are typically fixed, right? For example, sensors, video cameras, elements which doesn't move but actually generate a lot of data. So if you look at from different countries, all these spectrums have already been carved out. As Duncan mentioned, the WRC has already allocated these spectrum for IMT. And this is where most of the 5G is going to be truly adopted. And this is the main aspect in which how we see even in Africa, that this revolution of the regulation to actually allow the operators to actually operate in this space will provide the true differentiation compared to a traditional 4G network. The other aspect from a private 5G network, if we look at it, is the ability for the private enterprises to actually roll out their own network is typically was mainly hindering from a cost perspective. While it was possible even from a 4G or a 3G point of view for industries to roll out their own private network, there were a couple of primarily from a capital expenditure point of view was pretty cost prohibitive, because of the amount of investments which had to be made to actually build these radio networks, which were typically vendor locked, and maintaining of these would be extremely expensive for a industry who may not know how to operate it in an optimal manner. 5G by default works in a different manner. And one of the key aspects for the 5G is the radio access network, which is powered by ORAN or Open RAN. The ability from an Open RAN perspective is it's basically built on, rather than having the radio unit, the data and the control unit present in a single box, the aspect is built on disaggregating the radio data and the control unit, and basically making the data and the control unit rather as a software form factor as compared to as a hardware form factor, which today it relies on a more traditional 4G or a 3G network. What this provides is the ability for enterprises to actually deploy multiple radio units, but actually being controlled by by DUs which are not, which doesn't need to be in the same place as where the radio units is. So since these data units and control units are either available in a virtualized form factor or as a container form factors, these can actually be centralized and deployed on COTS or commercially off the shelf hardware rather than vendor locked hardware. So that itself provides the ability for to reduce the overall cost, because now you're not paying for buying these expensive radios which has all these different entities in one box, but rather just buying off the shelf servers at a cheaper price, and all the main components of the 5G radio access network is actually deployed as a software form factor compared to a hardware form factor. This not only allows the industries to actually scale in a very rapid manner, but also to customize how they want to actually build the network, right? And this becomes a more powerful aspect when we are looking at deploying private 5G. So specifically, the entire aspect of 5G Open RAN has brought in has made a commercial sense of industries to roll out their own 5G network compared to the previous generations. The other aspect is primarily due to this split of the radio unit and the data unit. The radio unit, which is basically the antenna, that cost has substantially reduced, and there's already discussions about sub $1,000 radio availability, which can effectively be utilized for building these 5G subsystems. The next concept in the 5G, which is one of the key differentiators and what has made adoption of building private 5G truly valuable for an enterprise, is the ability for it to perform network slicing. The concept of network slicing is extremely simple. The objective is to take a single physical network and to build different types of overlays on top of these single physical networks with different network characteristics. While this was possible in some ways in the previous generation, 5G has made it enabled in the native format. And this is the reason why this is available, is because in the 5G protocol stack, there's an introduction of a new layer called as SDAP, which allows to facilitate different quality of services in layer 2 compared to the previous generations, which did not have this layer present at all. What this means is, in effect, for an enterprise where there are different requirements, primarily around fixed broadband access for their employees. It could be IoT for their sensors. It could be AI ML for for automation or robotics, or it could be virtual reality for design. Depending upon these different requirements, the ability for the network to provide and to scale the network depending on the use case is where the true importance of 5G is actually realized. And for an industry where it is not possible for one network to fit all, this becomes a very important factor. For example, if you look at mobile broadband, the requirement for mobile broadband would be an okay-ish latency, a good throughput, a higher download speed compared to a lower upload speed. Compared to the same thing when you come to, let's say, video surveillance or video analytics, where you would need a higher upload bandwidth compared to lower download, and you need a lower latency compared to the traditional broadband use case. And similarly, the same goes, for example, for IoT, where you do not need higher bandwidth, but you would actually need lower latency. So this kind of changes is very important from a true 5G point of view. When we look at from a 5G cloud native architecture, the next add-on in terms of enabling enabling the enterprises to adopt is the ability for, rather than relying on these expensive systems which for packet core or maintaining these different elements, the ability for utilizing open source software for managing these solutions is the next big trend in terms of why private 5G is now much more easier to adopt compared to the previous generations. And specifically in these areas, Kubernetes and OpenStack are fundamentally playing a very important role in private 5G deployments. And the reason behind this is the ability for one, because many of the in many of the 5G components, from the CU or the DU or to the packet core functionalities, have all been made available as microservices or small scale virtual machines, rather than one big unit which would be very expensive to run. And these units can independently be scaled depending upon the different applications which requires different ways in which the network should be designed. And with OpenStack and Kubernetes, what it allows is for an enterprise to not spend heavily on expensive licenses, and also the ability for them to scale up and scale down the network depending on the utilization. So this provides them for them to actually start small and scale up without incurring massive cost along the way during the scale up procedure. And not only just that, there's a whole bunch of, especially around Kubernetes and OpenStack, there's a whole bunch of open source initiatives which are planned specifically to enable for enterprises to not only just use it for 5G deployment, but actually use the same infrastructure for actually deploying their own applications for, let's say, industrial control, security, for network function virtualization, or even for some of the next generation technologies such as blockchain, AI, ML. So this has completely enabled for the industry to adopt the private 5G, and it's now what was seamlessly thought as not feasible for a single enterprise to roll out their own 5G network. It is now seemingly much more easier because of these standards. As we mentioned, one of the key aspects is if you look at it, 5G has been built keeping open standards in mind. Whereas the previous generations were more about vendor lock-ins, and you had to stick with a specific vendor for the entire, right? If you buy a radio unit from a specific vendor, you had to stick with the same vendor till the packet core, right? You didn't have the options to pick and choose, thereby making the value proposition very expensive. With the introduction of 5G, keeping cloud native as first and keeping open source and open standards as the primary drivers, it has now made it very easier for anybody to actually build their own 5G, like a DIY kind of network compared to the previous generations. Specifically, one of the key aspects is around ORAN, which primarily avoids the vendor lock-in specifically between the radio units and the control and the data units. This effectively means that industries can scale much quickly, and they can go with the vendor of choice and not get into vendor lock issues where everything had to be supported by a single vendor. In addition to that, there is also elements in which even the 5G packet core is actually available as open source, or through non-traditional vendors who typically were not in the business of providing previous generation technologies or packet core. These have also entered the 5G packet core businesses, where they are able to actually provide these different use cases with slicing as an option directly available in the packet core management itself. And the fundamental drivers, obviously, behind 5G adoption is always Linux, Kubernetes, and OpenStack. These has been very, very important to ensure that there's good amount of motivation for private 5G drivers, and to keep the costs low so that these networks are not seen as something which industries cannot adopt or rather have to rely on an MNO to actually roll out, but rather build themselves and go from there. And one of the important final aspects is around the 5G components. Every 5G component today are designed to run on commercially off-the-shelf hardware, right? And this is one of the fundamental difference between the previous generation and this. The reason once you start putting it on commercial off-the-shelf hardware is the ability to buy cheaper servers and actually deploy these at scale. So you could start off with a limited scale and limited functionality as a trial basis and then scale up without incurring heavy additional cost as you continue through the scale up process, which is very, very important for specifically from a 5G, private 5G point of view, who do not have access to immense amount of consumers who are logging in or are generating actually revenue from this network, but rather utilizing it to support their existing network. The final aspects from an open source perspective is from a network slicing and network virtualization point of view, the software defined networking projects such as Tungsten.io or OVN, they have actually played a key and central role, because in effect, as you continue to deploy these different elements, there's an ability to stitch these networks in a software form factor rather than a hardware form factor. So rather than somebody going up to the box and plugging in wires and switches, the ability to do that in a software form factor and be able to connect different elements in a virtual fashion at a click of a button is what these open source projects have made it enabled. And these has been adopted by various different, not only just service providers, but actually true private 5G players to actually incorporate into their network. So if you go to the next slide, so this is an example of the key open source framework which are powering 5G. ORAN, you have OPNFV, the Linux Foundation, Docker, Kubernetes, OpenStack. All these different frameworks are working towards building a true 5G, a place where in which you have different components which can be leveraged to actually roll out 5G in a very, very cost-effective manner. And most of these are not just hobby projects, but rather, industrial framework which has been adopted by different service providers, and there are service providers who are actually now supporting these frameworks and adopting them in-house as well. So with that in mind, I would like to hand it over to Duncan to finish his closing statements on 5G status in Africa. Duncan, over to you.
Thank you very much, Pramod. I think the next two slides is to show that what we've been speaking about, private 5G private networks, it's real. It's something that we are seeing already happening in some parts of the world. And the case studies or the few slides that we've put here are specific to region 1. The reason why we think it's best to highlight what is happening within region 1 is because as Africa, we are in region 1, the same as Europe. So the devices that have been manufactured by the technology vendors, or just the software development, it's much easier for us to align with those within the same region as us. So looking at this slide, the one there on the top right that's from November last year, November 2019, when Germany opened doors to invite manufacturers to apply for licenses for 5G. And this was in recognition of all the benefits that Pramod just spoke about, that private enterprise having its own network would be able to use it to drive scale and efficiencies within their operation. Soon thereafter, or we see on the bottom left there that Finland also followed suit and issued its first 5G licenses, and also, more importantly, urged the industry to pilot because they also see the benefits of private 5G. On the bottom right, it's a study that was done by IDC, which I would invite everyone to lay their hands on and read about it. So it's always good to see an independent research company also weighing in with their expertise and opinions on just how they see things panning out. And on the top left is the European 5G Observatory. So this body is, basically researches and looks at what is happening in the 5G space across the different European countries. And specifically here, it's the 5G private license spectrum. So as we mentioned at the beginning and during Pramod's presentation, that any building of a 5G network requires spectrum. And what we are seeing with these countries is specifically and deliberately awarding spectrum to the enterprises so they can then manage it end to end. The spectrum, the devices they are using, and the operation and maintenance of that network. We believe it's something that would follow suit within our continent. And this is the last slide really to close and say today, as we speak to you, what do we see as the status of 5G in Africa? What we are seeing is that the services are still limited. There have been reports of South Africa and Lesotho having started work around that. In Lesotho, it's the central bank and some mining company that are trying 5G. In South Africa, Rain, the operator, is reported to be trialing with a limited number of customers in Johannesburg and Pretoria. Analysts also are forecasting that the first countries to have commercial 5G offerings in Africa will be South Africa, Kenya, and Nigeria, which is something to be expected because these countries are influencers in their region, and it would be good for the entire continent if they start moving towards 5G, because we then expect to see those countries neighboring them to also adopt 5G and possibly use the models that they have adopted. The interesting one is the one that I'm about to go to, that the initial 5G customers would be through private networks, and these would be enterprises and the public sector. So this, I think it's in line with the rest of the presentation that we did, that 5G offers opportunity to be able to cater for different segments in the market, be the mass market that's looking for mobile broadband, or the enterprises that want to take advantage of extra low latency and the likes. Obviously, these being new, these challenges that we need to address as a continent. The first one being that the governments are yet to develop regulations that will allow 5G rollout. We also want to believe that this is something that's being looked at, and our urge would be for governments to expedite this, as we showed in the first slide, that by 2023, 6G would have been released, and by then the 4G, which is pervasive in a lot of the African countries, would be about 10, 11 years old. The other key consideration is that the incumbent MNOs haven't developed the required business models for 5G. That business model today is centered around providing mobile broadband to other customers, but not necessarily to offer bespoke solutions to drive enterprise efficiencies. And then spectrum auctions linked to the development of regulations is that the auctions are still to be conducted. We also believe that with the impact of COVID and a lot of countries hamstrung for cash, this may just accelerate the auctions for spectrum so that the country's fiscus can recover some funds. And the expensive investment that is needed to roll out 5G because of the proximity of the network, the new masts will be required and antennas, and this is investment that still need to be factored in the business cases. Having said this, we also believe that the opportunities for 5G within Africa are massive. 5G will allow us to have access to the internet much quicker, because today in some countries the last mile through fiber, it's still a challenge. And as we've mentioned, previous generations of mobile in terms of speed. So 5G would be able to circumvent that and accelerate the adoption of internet. What we've also seen in the last few years is the arrival and presence in Africa of global hyperscalers like Microsoft, AWS, Google should also be arriving soon. These would drive the growth and adoption of 5G, because a lot of the workloads and the computing power that would be required by the different enterprises would reside within these hyperscalers data centers. So connectivity at the right latency and throughput will be critical for efficient working of the business applications. And then the last opportunity that we want to speak about is just the development and growth of the different sectors. I think COVID has, in a way, made us realize the potential that technology can do to better our lives and improve it. And 5G will just add cap to this. So we expect to see tremendous development in health, telemedicine, education, precision agriculture, and all of these would be driven by lower latency, the speed that we can get, the growth for 5G and its pervasiveness. So all of these factors provide big opportunities that, despite the challenges that we mentioned, which will be overcome in the next few months or years, we then expect to see 5G growth. Okay. That's our website, www.inc.inc. We invite you all to please visit our website, learn more about our products, contact us for any discussion on the products and solutions we have on the website, and specifically around 5G, please reach out to myself, to Pramod, or through any of the INC channels, and we'll gladly have a conversation with you. Thank you very much for your attendance, for listening, and we really appreciate it. Thank you very much.
Thank you, Duncan and Pramod. That was really very interesting. As I said before we even started, this is a topic that's really close to the Digital Council's heart. It's part of our mandate, what we advocate for and what we stand for. So thank you very much for your time this morning. I really appreciate it. And again, just thank you from all of us at the Digital Council for your support, your financial contribution to this event. It really goes a long way towards keeping these conversations ongoing and including all of Africa this year in this bigger conversation. Thank you, and we look forward to engaging with you in future.
Thank you.
Thank you for participating in this session of the Fiber Connex 2020 conference.